Okay, so in 7.4, we're looking at some basic concepts of probability. All right, so it's important to make sure that you understand 7.3, right? And in 7.3, you did learn that the probability of an event equals the number of outcomes of that event over the number of outcomes of that sample size. So it's important to understand that 7.3 section. So let's take a look at an example here. What if I said that I wanted to know the probability? Let's start off with saying that a single die is rolled. I want you to find the probability of rolling a 5. All right, so this is a 7.3 example, right? An example, let's just say from 7.3. Okay, so first of all, we have to understand that our sample size here, you roll a die, just one, and you can get either a 1, a 2, a 3, a 4, a 5, or a 6. All right, so those are the possible outcomes of rolling one single die. All right, we want the probability of getting a 5. Well, we see that there's only 1 5, right? So we put a 1 up there, right? That represents that there's only 1 5, but there's a total of 6 different outcomes. This fraction doesn't reduce any further, so this answer is 1/6. All right. Okay, so now let's start taking a look at the examples that you're going to see on your 7.4 homework, right? Once again, we want to understand this basic concept so we can continue on. Okay, so these are examples from 7.4. This specifically looks like it's number 3, and I'll just go through your problems in my homework assignment. So we have a pair of dice is rolled. We want to know what is the probability of getting a sum of 5. So this question is a little different because we have 2 dice that are rolled, and we want to know the probability of getting a sum of 5. So the first thing that we do have to understand is the sample size, right? We need to be able to know how many dice do we have, or how many possible outcomes there are. So I'm going to show this with the little picture here so we can see this. So let me go to my camera. I'm going to have this up on YouTube or on Google. I just typed in paired dice possibilities. All right, so we'll go ahead and use this here. All right, so what we notice here, just put this on the next page. What we notice here is that we have, well, in this first row, right, if we take a look at all of those, we have 1, 2, 3, 4, 5, 6 possibilities. Right, so the next one, so the first row is 6 possibilities, the next one was 6, the next one is 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 6. How many do we have in total? 1, 2, 3, 4, 5, 6 of them. We can add all of these up, right? Or, right, 2, 3, 4, 5, 6 of them. Or we can multiply, all right? But we see we get 36 possible outcomes. So that's very important to understand. Let me not. I get 36 possible outcomes. So what makes this problem different from the previous example? This first example, it was one single die is rolled. This was our sample size, right? Just the numbers 1, 2, 3, 4, 5, 6. But now we have a pair of dice is rolled, right? A pair of dice is rolled. So these are all the possibilities, which is a total of 36. Right, so that's very important to understand. Back to the question. What's the probability of getting a sum of 5? Right, so we want the probability, right, of getting a sum of 5. So now we need to look for all of them that equal 5. Right, so which ones equal 5, right? Well, we have a 1 and a 4, right? We can do it the other way, a 4 and a 1. We have a 2 and a 3. We have a 3 and a 2, right? So the probability of getting a 1 and a 4, well, that's just 1 out of the 36, right? The probability of rolling a 4 and a 1, well, once again, you can only get that one time out of all the 36, right? Which means all of these will be 1 out of 36. So in order to find the probability of getting a sum of 5, all we have to do now is just add these. Or you can do 4 times 1 over 36. Right, so you do 4, your open parentheses, 1 over 36, close parentheses. If you get a decimal, just change it to a fraction. And we see that this answer here is 1 over 9. So a nice example there in finding probability of getting a sum of 9. Okay, next example. What is the probability of getting either a sum of 5 or at least 1 4 in the roll of a pair of dice? So we got 2 things here, right? First, we're looking for the sum of 5. Now, once again, we saw something like that. These are your possibilities. All right, these are the possibilities, and we know that the probability of each one is that. But now the next part is interesting. It says, or at least 1 4 in the row, which means it can be 1 over 4, right? 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4. Or it can be the other way, right? It can be 4 1, 4 2, 4 3, 4 4, 4 5, and 4 6. But if we see any of these over here, we don't want to show them again, so we cancel those off, right? We don't want to repeat them. Okay, so I see a 1 over 4, so that's gone. I see a 4 over 1, that's gone. Looks like that's it. Now in here, if we see any that are repeating, identical, the same, we want to cancel those off. Or at least one of them. Because we never want to show two of them. We just want one of them. I see a 4 over 4 and a 4 over, and a 4 and 4. Sorry, we're saying over, so I just cancel one of them. Okay, and we know the probability of each individual one is 1 over 36, 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 and 1 over 36. So the probability of this event, well, how many 1 over 36s do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, would just be 13 times 1 over 36. And we do that math, and that gives us 13 over 36. So a nice example there. Okay, now we are looking at some other examples. And before we take a look at these examples, this is in regards of odds in favor. All right, so that tells us to find the odds in favor. It's the probability of an event over the probability of that event, of the complement of that event, or that event not occurring. All right, so let's take a look. We have a single fair 6-sided die is tossed. Find the odds in favor of rolling a 1, 2, 5, or a 6. All right, so let's find the probability of getting a 1, 2, 5, or a 6. All right, because this is a single, just one die, each one of these is just 1 over 6. All right, so the probability of getting one of these, all right, is just 4 times our 1 over 6, right? And that gives us a 4 over 6, which reduces to 2 over 3. But now we want to find the probability of not rolling a 1, 2, 5, or 6, which means you would have to either roll a what? A 3 or a 4, right? Because if you don't want a 1, 2, 5, or 6, that means you want to find the probability of getting 3 or 4, which is just, this is 1 over 6, that's 1 over 6. Right, so the probability of getting a 3 and a 4 is just 1 over 6. I'm sorry. We got 2 times 1 over 6, which is just 2 over 6, or in other words, 1 over 3. So now we use these two numbers, right? And we set up our fraction. We have 2 over 3 over 1 over 3. All right, and then from there, you use your calculator. You should be able to work this out as well. This is just 2 over 3 times the reciprocal of that. 3 over 1 cancels out. So they'll have 2 boxes. It says this, 2, that. All right, we get 2 on the top, 1 on the bottom, so it's 2 to 1. All right, so a nice example there. Let's take a look at our next one. A single fair die is tossed. Find the odds in favor of rolling a number greater than 1. So once again, it's just one die, right? So the probability of it being greater than 1, well, which numbers are greater than 1? We got 2, 3, 4, 5, and 6. And the probability of these, well, each one of these is 1 over 6. Right, so the probability of being 2, 3, 4, 5, 6 is just 4 times 1 over 6, which is 4 over 6, which reduces to 2 over 3. So we want now, once again, we're always doing the opposite, right? So now we want the probability of it not being 2, 3, 4, 5, 6, which means if it can't be that, your only option is 1. And the probability of it being a 1 is 1 over 6. So now we use these two numbers. We have 2 over 3 over 1 over 6, which gives us a 2 over 3 times a 6 over 1. And this reduces, well, that's a 1, that's a 2. I'm sorry, how many do we have here? 1, 2, 3, 4, 5. Let's go back. Right here I have 6 of these, so it shouldn't be a 4. It should be a 5, which now changes this to a 5 over 6. And it'll change this up here to a 5 over 6, which will change that, right? 5 over 6 times 6 over 1 cancels. We're left with 5 over 1. Once again, it's 5, 2, 1. All right, so some nice examples there. And let's take a look at these last two that you have on your homework assignment. Once again, I'll take a picture because these are pretty nice examples, even though they look a little lengthy. All right, so we take a look here. It says an experiment. Oh. An experiment is conducted for which the sample size is this. Is the following probability assignment possible for the experiments? Well, remember that probabilities will always sum. They should sum to equal 1. And after adding them, we see that they do not. So this is why this answer is A. No, because they do not add to equal 1. So all you have to do is just use your calculator, add those up, and see how that works out for you. Okay. So a nice example there. Let's take a look at our last example in this homework assignment. Okay, an experiment is conducted for which the sample is this. Is the following probability assignment possible for this experiment? So are these numbers possible? Right? Well, definitely not, because a negative, right? Negative probability is not possible. You can't say the possibility of it raining tomorrow is negative 5%. Doesn't make sense. So this is why this is the answer, because probabilities have to be between 0 and 1, which makes them positive numbers. And that completes 7.4. If you have any further questions or